Okay, question 2. So we're given a triangle OAC, okay, with O equals the origin, and we've got the position vector of A, okay, as little a, and position vector of C as little c. Okay, so remember now the position vectors describe the location of those points A and C, in this case, relative to the origin. Okay, now, of course, it does create a triangle, okay, and it says then that this point is a point E that divides the line AC in this sort of ratio 3 to 2. So I've sort of drawn this out and I tried to get like an accurate sketch here so I could sort of show that ratio, so I could see visually, I could see what's going on. And E is going to go here, isn't it? Because what I did was, because it's in the ratio 3 to 2, yeah, so AE EC is in that ratio here. The line A to C I sort of measured out and then split it up into 5 equal parts. So then you can see then AE is going to be 3 parts, EC is going to be 2 parts. Now we want to describe the position vector, okay, of E. Okay. Now as we saw in the first instance, right, we know that we sort of, in order to answer this, in order to get E, we need to know what this vector is here, AC. We saw that in the first one. We really need to know what that vector is. So let's work that out to start with. Okay, so AC, okay, and it's easy, isn't it? Because it goes back to the basic stuff we did at the beginning. A to C is the same as A to O, okay, A to O plus O to C. Okay, so there's the equivalence there. From again A to C, you can go A to O, O to C. This is the same displacement. You start at A, end at C. Okay, now of course A to O is going that way, so it's the reverse of this vector, so that'll be minus A. And then O to C is along here, so that'll be positive C. So you end up with C minus A. Okay, kind of like a standard result this. If it was A, B, it would be B minus A. If it's AC, it'll be C minus A. You always get that. Okay, so now let's consider what they actually want. They want us to find out, the position vector of the point E. Okay, so we effectively want the coordinate, yeah, of E. That's what we want, but of course we want it in terms of vectors. So how do I get to E from the origin? Okay, because when we think about coordinates, we want to see how do we get there from the origin, don't we? So how do I get to there? Well, of course, we write it as OE, don't we? Okay, right? So going from O to E. Now, O to E, we see as going, first of all, from O to A, yeah? Plus then A to E, okay? So that's the route to get there, isn't it? I mean, you could go along here if you wanted to. I know some people would go that way, OC plus CE. But because I worked out AC, I'm tending to go, I think it's easier to do it this way, right? And you'll see why in a minute now. So from O to E, think of as going O to A and then A to E. Okay. Now, of course, we know O to A is little a. I mean, if you want, you can put that in straight away. Okay. A to E, we don't know, but we do know A to C, as we saw in question 1. A to C, and A to E is a fraction of A to C, isn't it? If you think about it, it is a fraction. Now the question is, what fraction is it? Well, because we've got this ratio, it becomes really easy. Because if you think about it, to get from A to E, we're only moving along 3 parts out of the total journey, the total distance of 5 parts. So you can think of AE as a fraction of 3/5, okay, of AC. Okay, because it is, isn't it? It's 3 parts of the journey, okay. Because the total journey from A to C is 5 parts. To get from A to E is only 3 parts. It's 3/5 of the way, so it's 3/5 of AC. And all you've got to do then to finish off is substitute in what AC is, which is C minus A. Okay, and then you can multiply out that bracket and then simplify. It's really easy then to simplify. So you've got A here, take away 3/5 A, so there'll be 2/5 A, and then you've got 3/5 C there, and we're done.